Okay, for this question, we're supposed to pick from these three chi-squared tests. Before we do that, just a quick idea of what each of these mean. The test of independence is when you're trying to compare two categorical variables and you want to see whether they are, dependent on one another, whether they affect one another, or whether they're independent of one another. Okay, and this is usually where you see a contingency table. So if you can imagine the data being put in like a table like this, where maybe this is gender, and then this would be, oh, let's say good, okay, or bad, some sort of like categorical rating or some sort of category you can put them in. You could test to see whether gender is independent of ratings, or whether gender, if it's true that gender is dependent on ratings, that means a person's gender is impacting what their ratings are. Okay, so that's a test of independence. A goodness of fit test is a test to see whether your data follows a certain distribution. So we do this like if we want to check to see if our data is normally distributed. I guess a lot of the questions we're going to see in Newton are going to be questions where there's an expected amount, and then there's what we actually get with our data. So actually, they usually say observed here. Observed. Okay, so again, you could put these in columns. That might make it confusing with the test of independence, but just remember, the difference is the goodness of fit test is comparing some expected amount to some observed amount. So maybe, like based on some previous theory, you expect to have 20 of some variable one day, 40 of them another day, and then I'm just keeping it simple here. We actually get 30 one day, 30 another day, and 20 on the third day. You could test and see whether your observed numbers, the data that you actually collected, you could test to see whether it's different enough than this expected amount. Okay, and those numbers are certainly different right now, but they might be close enough to the expected amount so that we can't say it with certainty. That's why we use statistics. Okay. So that's a goodness of fit test when you compare your observed amounts to your expected amounts. And the test for homogeneity is a test to see whether two columns of numbers come from the same population. So like you've got blood pressure for one group of people, for group A, and you've got blood pressure from group B. You can test to see whether these two came from the same population or not. Okay, so now we know the three of those. Let's check out the problem here. A hospital is trying to compare the weights of babies born at night and babies born during the day. They collect a random sample of weights for babies born at night and during the day and record the distribution of each. They want to compare the distributions to see if they are the same. So which of the following chi-squared tests should be used in this situation? So that matches a test for homogeneity like we were talking about. We're trying to see if those two babies have the same, are coming from the same population. If this test is significant, then we're going to claim that babies born at night have different weights than babies born during the day. Okay.